Morning, everyone. Welcome. You can see people starting to come into the room. We'll give it a couple of minutes just to let people come in before we get started. Okay, hi everyone. Good morning. Welcome to today's Innovation Showcase. My name is Lauren Rowett. I'm the Acting Industry Manager here at ecologiQ. And with me, I have Lily Rose Palmer, Senior Industry Advisor, helping out as well. Before we get started today, I would like to acknowledge that this meeting today is taking place online. However, so it is taking place on many parts of country. I'm in Melbourne today, and I acknowledge the Wurundjeri, Woiwurrung and Bunurong Boon Wurrung peoples of the Kulin Nation and pay respect to their elders past and present. I also extend that respect to any First Nations people who might be dialing in today. I acknowledge the continued deep connection to land, sea and sky. Sustainability is often seen as a fairly new concept. However, First Nations people have practiced sustainability for over 60,000 years. And I hope that we can respectfully learn from the knowledge and experience of one of the longest continuing cultures in the world. Before we get going, I'll just give a really brief overview around ecologiQ. So we're a Victorian Government initiative tasked with implementing to optimise the use of recycled and reused materials in Victoria's major transport infrastructure projects to reduce waste and to contribute to a circular economy. The way we do this is through the Recycled First policy. So implemented in March of 2020, the policy requires that all tenderers of Victorian big build projects must consider and demonstrate how they will incorporate recycled and reused materials into that project, and also report on their use before, during and at completion of construction. This data component is super important. It not only shows us how much recycled material we've been using, but also helps to give us insights into the market and know where our efforts are best placed. Speaking of data, as at the end of July, the policy has seen 4.6 million tonnes of recycled material used in big build projects, which is fantastic, really big numbers there, and 4 million tonnes committed. For those of us online who like to count in MCGs, that's 1.75 MCGs of recycled material. Joining us today, we have our three fantastic panelists. I'll ask each of them to unmute and just introduce themselves. Andrew, if you'd like to go first.
Good morning, Lauren. Good morning, everyone. Andrew Papkostas, Principal Engineer, Pavements and Materials within the Department of Transport and Planning. One of my core areas of responsibility relates to the development of specifications and technical standards, and that involves liaising with industry in regards to proposals to introduce new materials into road construction, particularly in my case, the pavement space. Thanks, Lauren.
Thanks, Andrew. Irina?
Hi, everyone. My name is Irina Kosteska. My role is Deputy Director Engineering at MRPV. So me and the engineering team are very much involved in supporting ecologiQ and ensuring that the Recycled First policy is implemented on projects. We also work on removing any barriers, which is kind of a result of, let's say, insufficient standards or outdated standards, and work very closely with DTP to kind of develop specifications and new standards and approved materials, which are kind of supporting Recycle First.
Beautiful. Thank you, Irina, and beautiful. Lovely to have both you and Andrew back. We have a new panelist joining us today as well, Stephen Howe.
Good morning, and thank you for that. Yes, I'm the Director of Engineering Solutions and Innovation at the Level Crossing Removal Project. My role is to work with our alliance partners across the whole program on things like optimising standardised solutions for various design elements of scope, but also in the innovation space, bringing about the use of innovative materials and also sustainable materials, which is why heavily involved in the Vita-wide low carbon concrete working group, which looks at obviously sustainable concrete, but also other sustainable materials and innovative materials to bring into the big build. Thank you.
Beautiful. Thank you so much, Stephen, and welcome. One last thing from me before we get started. So just a bit of housekeeping. We have 3 suppliers joining us today: Aero Insulations, Link Asia Pacific, and Spider Tie. Each supplier will give a 10-minute pitch, and following that, we'll have 10 minutes for Q&A with the panel. Audience members, if you have any questions for the suppliers, please do use the Q&A function down the bottom of your screen. It'd be great if you can just write the name of the supplier who your question is for, just so that they know which ones to answer, and they'll pop in there after their presentations and answer them for you. So without any further ado, I'd like to introduce Walter from Aerofill. Take it away.
Can you see me and hear me? Yeah.
Yes, we can.
Awesome. Good morning, everyone. My name is Walter, and I'm the Managing Director of Aero Installations. It's an absolute pleasure to be here today. I'd like to thank Lauren and team for the opportunity to pitch our Innovations August Innovation Showcase. Now, Aero Installations was founded in 2023, and we're currently operating from Melbourne, where we have our manufacturing facility and warehouse. Next slide, please, Lauren. Today, I'm very excited to introduce Aerofill, which is our latest product innovation. Aerofill is a revolutionary void filler made from recycled expanded polystyrene, cement, and a polymer-modified binder. It addresses key environmental challenges while offering significant advantages in performance and cost-effectiveness. In this brief presentation, I'll demonstrate how Aerofill is transforming the industry by providing a sustainable alternative to traditional cementitious materials. Next slide, please, Lauren. As we all know, the construction industry is one of the largest contributors to carbon emissions, in particular due to the extensive use of traditional material like cement. Cement production alone is responsible for about 8% of the entire world's CO2 emissions. Simultaneously, the industry struggles with significant waste management challenges. Every year, millions of tons of EPS are produced and consumed globally, with a substantial amount ending up in landfill due to inadequate recycling processes. In Australia, over 55,000 tons of EPS is produced yearly, but only 7,800 is recycled. These are numbers from 2021. Now, recycled EPS is then incinerated or extruded, further adding to the CO2 emissions. A part of this incinerated EPS is then shipped overseas to countries like Malaysia to be remanufactured into skirting boards and picture frames, making it a non-circular recycling chain. A lot of EPS producing companies in Australia are doing a great job with their recycling efforts, mainly extruding EPS into XPS. Industry initiatives such as Styrocycle from the EPSA are also great in raising awareness of the recyclable aspect of EPS, which, if you didn't know, is 100% recyclable. Traditional void filling material can be heavy, costly, and inefficient, requiring significant amounts of cement and offering limited lightweight, insulating, or acoustic benefits. Now, these materials often overlook the potential to recycle and repurpose waste, such as EPS. These challenges highlight the urgent need for sustainable construction material that reduces environmental impact and makes use of recycled waste. This need is driven by growing regulations and the rising demand for green building practices. Despite all of these pressures, the market often lacks cost-effective, high-performance solutions that align with environmental goals. This gap offers a unique opportunity for innovative products such as Aerofill that can redefine construction standards. Next slide, please, Lauren. Aerofill complies with the NCC, BCA, and building standards, ensuring it meets the rigorous demands of modern construction projects. Aerofill offers a groundbreaking solution by turning EPS waste into a valuable resource by combining recycled EPS with cement and a bio-based polymer-modified binder. Aerofill not only cuts down on cement use, but also converts EPS waste into an efficient void filler and insulating screed. This process reduces landfill waste and lessens the need for virgin material. The use of a bio-based binder further minimizes the carbon footprint, making Aerofill a standout product in sustainable construction. Aerofill's unique composition delivers superior insulation and acoustic properties while maintaining structural integrity and reducing the carbon footprint of construction projects. This innovative approach aligns with global sustainability goals and offers a practical, eco-friendly alternative to conventional material. Next slide, please, Lauren. Aerofill's lightweight nature greatly reduces the structural load on buildings, making it ideal for projects where weight is a critical factor. It offers exceptional thermal as well as acoustic insulation capabilities, ensuring that buildings stay warmer in winter and cooler in summer, leading to substantial energy savings over time. By integrating recycled EPS and the bio-based binder, Aerofill significantly cuts down on CO2 emissions associated with the production and disposal of building material. The use of Aerofill can lead to lower overall construction costs due to its ease of application and reduced need for additional material. Aerofill not only utilizes waste EPS, which would otherwise end up in landfill, it also encourages the recycling loop within the construction industry, supporting global sustainability initiatives. Aerofill's composition ensures it's durable and requires minimal maintenance over its lifespan, reducing long-term costs for asset owners. Next slide, please, Lauren. Aerofill's versatility is one of its standout features, making it ideal for a wide range of applications across residential, commercial, mining, civil, and specialized sectors. In residential settings, Aerofill excels in slab insulation due to its great thermal conductivity. It's also the preferred choice for renovations and extensions, where cost-effective and energy-efficient properties can enhance the thermal performance of floors, thereby reducing heat loss and energy bills. In the commercial sector, Aerofill creates inviting and comfortable environments in retail spaces by providing a solid foundation for various floor finishes, while also offering exceptional thermal and acoustic insulation. Other applications are warehouses, distribution centers, cold storage facilities, where maintaining consistent temperatures is crucial for storage and logistics. It can be retrofitted onto existing slabs to provide better thermal performance, and is also used in manufacturing facilities to support efficient production processes by providing excellent load-bearing capacity and thermal insulation. Moreover, Aerofill is an excellent solution for environments requiring significant sound reduction, such as schools, hospitals, helping create a quieter, more conducive spaces for learning and healing. In mining, Aerofill offers a significant advantage over traditional cellular cement fill, with a reduction of 50% in cement and CO2 emissions to reach the same compressive strength results, while maintaining structural integrity, by default offering a lightweight alternative. Civil applications include lightweight void filling where ground conditions require so, thermal backfill around cables, acoustic backfill, trench backfill, redundant pipe fill, ground reconstitution, backfill of drill and pile holes, and more. In road infrastructure, Aerofill can form part of the pavement makeup, reducing the total weight of substandard or reactive soil in the same way as geofoam or EPS pods would do the same, offering a cost-effective alternative to traditional fill, but most importantly, repurposing a large quantity of recycled material. Other specialized applications we have been contacted for in using Aerofill as a recycled thermal and acoustic fill for hollow core brick walls instead of using grout or sand and cement, or making recycled insulated blocks, building blocks such as Basa blocks. All of this clearly demonstrates the versatility of Aerofill. Now, next up is a video of an installation of Aerofill, which is used as an insulating screed in an older building with weight restrictions. And then next slide, we have a few photos where you can see before and afters of Aerofill being installed as an insulating screed, and a few photos of cellular cement, cellular concrete installations where Aerofill could be an immediate replacement, offering a 50% reduction in cement and using fully 100% recycled aggregate. Next slide, please. As part of our commitment to innovation and sustainability, we've established strong collaborations and partnerships that enhance our efforts and extend our impact within the industry. Firstly, we're very proud to be part of the Innovate to Grow program that we are currently participating in by CSIRO. We're actively engaged in clean energy and low emission initiatives, and this partnership not only supports our R&D efforts, but also aligns with our mission to lead the way in sustainable construction. We're listed on the Recycle First directory of ecologiQ and the Buy Recycled directory of Sustainability Victoria. Additionally, our membership at Master Builders Victoria and the Concrete Institute of Australia further strengthens our position in the industry, giving us valuable insights, resources, and connections to help drive our projects forward. We actively participate in key industry events such as Sydney Build 24, the Vic Transport Conference, and the What's New in Concrete Conference by the CIA. These events not only allow us to showcase our innovative products, but also to stay ahead of industry trends and collaborate with other leaders in the field. Through these partnerships and our involvement in these events, we continue to push the boundaries of what's possible in sustainable construction, ensuring that we deliver cutting-edge solutions that meet the needs of today and tomorrow. Next slide, please, Lauren. We're focused on the market penetration by creating engagement through industry events, collaborations, and targeted marketing efforts. Our goal is to establish Aerofill as the go-to solution in the construction industry when it comes to void filling or insulating screeds. Innovation is at the core of our business. Through partnerships with industry bodies such as the aforementioned CSIRO and leveraging Kickstart programs and grants, we continuously innovate and expand our product offering. Forming the right strategic industry partnerships is a cornerstone of our business model. These collaborations enable us to extend our reach and enhance the value that we deliver to our customers. We're committed to building strong relationships with customers and key stakeholders, including government bodies and partners, to facilitate the scaling of Aerofill across various markets. Our vision is for Aerofill to be widely used across Australia as a sustainable and circular void filler and insulating screed. We plan to become part of the Styrocycle chain, to establish our own recycling facilities in every state, and to support this growth to further our sustainability goals. Next slide, please, Lauren. So as we've discussed today very briefly, Aerofill is more than just an innovative product. It's a vital step towards a more sustainable future for the Australian construction industry. By choosing Aerofill, you're not only investing in high-performance, eco-friendly material, you're also aligning with the growing demand for sustainable practices that meet and exceed industry standards. Aerofill sets new benchmarks in building material by utilizing fully recycled EPS, reducing CO2 emissions, and offering superior performance. We invite you to join us on this journey towards a more sustainable and efficient construction process. Whether you're planning a residential project, commercial development, or on a large-scale industry and industrial endeavor, Aerofill can provide the solution you need. We're very much ready to partner with you, offering not only innovative material, but also the support and expertise needed to ensure the success of your projects. For more information or how to discuss how Aerofill can be integrated on your upcoming projects, please reach out to myself or my team. Let's collaborate and make your next project more sustainable and cost-effective. I now welcome any questions that I'm sure the panel might have.
Beautiful. Thank you so much, Walter. Irina, I can see you switched on first, so take it away.
Thanks a lot, Walter. From what I understand from your presentation, you don't have any barriers to use this material within Australia. Is that right? I mean, it's all the kind of...
yeah, not really. At the end of the day, yeah, you're right. At the end of the day, all the components that we use in the system are all stuff that's used widely in the building industry. Like EPS is used as waffle pods widely. Even geofoam is used very much. All we're doing is using components that are currently being used, combining them together and making something innovative, something that we can use in a different way.
Yeah, so I guess I can see that the products are predominantly used for insulation or for void fillers, I guess.
Yes,
depends what the application is.
Yeah.
I'm more interested in the roads or infrastructure space.
Yeah.
You've mentioned that can be used for trench filling or kind of behind
absolutely.
walls and stuff.
Yeah.
Can you, in terms of durability and strength, in terms of that material, how does that compare with, let's say, typical crush rock backfilling of trenches or behind walls? I assume it's not porous, so it's not kind of conducting any water, so it's
Yeah. It'd be a lot more lightweight and it's fully recycled. But at the end of the day, when it comes to compressor strength or anything to do with strength-wise comparison with like soil, you said, we can play around with the densities. So we can make it stronger or less strong. Depends on cement content, depends on if you put polypropylene fibers inside of it, depends if you put sand inside of it. We can make it stronger or less strong. But as a backfill material, how does it compare? It's more lightweight, it's fully recycled. It's easier to get to the jobs. You need less trucks to go up and down because it's very lightweight. You can fill your trucks up fuller.
So let's say we want to use it to backfill trenches behind the curb, that's one area which is a bit of a lighter load, or under the road. Is that something that can be used under the road? And
definitely,
is the compressive strength there? And then the second question will be, over time, does it lose anything of the kind of the density that may potentially subside or sag, I guess, that area?
It wouldn't really use that much. We wouldn't really lose that much density, to be honest. Compressor strength wise, like I said before, we put some more cement in. We can get the strength up to 20 MPa if we put stand inside of it. With no stand, with just EPS cement and the binder, we can get up to 6-7 MPa. Now, I don't know how that compares to rolled soil after time, but we can definitely play around with those strengths. I think what's interesting is ease of installation. When you look at, for example, if you put a layer of our product in your subgrade, you don't have to roll it. You can just pour it, wait for it to dry, and then build your next layer on top of it. So there's a lot less sort of, I suppose, labor intensive to install it, because it gains its compressive strength from cement and its own sort of compressibility. Like EPS on its own has a certain compressive strength, so there's no air, there's no nothing inside of it. It's all just a solid material.
I mean, if anything, I would just suggest maybe some trials, in here, because obviously we're talking major infrastructure. I don't know if this is used for maybe more minor applications, backfilling smaller trenches in the kind of housing and properties, or it's in the major infrastructure with the kind of high expectations and longer lifespan.
Absolutely. So in mining, we do have a client that we're working with at the moment, but just because of mining, they only need a certain compressive strength between 1 and 2 MPa, which is pretty lightweight. And they get there currently with cellular cement or foam cement that they use. But that needs about 480 kilos of cement per cube to reach between that compressive strength of 1 and 2 MPa. Now we can get there with 260 kilos. So that's a reduction of 50% in their sort of environment. Now I haven't really explored the comparison between compressive strength or differences between filling up with soil. This is just going from the mining backfilling sort of proposition to roads. That would be a natural progression in my opinion.
Okay. All right. Thanks.
Thank you.
Stephen.
Yeah, thanks. Thanks, Walter. You're sort of touching on one of my questions, which is to do with, site time. Site time is often a limiting factor, particularly in, rail occupations or even just multi-story construction.
Yep.
So anytime you can save time, you're saving money for the client.
Absolutely.
So I'm just wondering how the construction time compares to alternatives, particularly with like when you can walk on it, when you can apply surface finishes to it. Is it just like other cementitious products in that regard, or is there any change to, when you could walk or apply finishes because of the EPS you got in there and the binder, which obviously, you'd be keeping your IP to yourself, which is fine, but I guess not knowing how that might interact with, the ability to walk on it or the ability to put, some other resilient finishing tiles or vinyl or whatever flooring on top of it. What can you tell us about that?
Walkability after 24 to 48 hours, depending on conditions surrounding, if it's a hot day, cold day, if it's a lot of cement, depending on the cement content too. So if you want to have a compressive strength of about 6 MPa, we need 600 kilos of cement per cube. Then that's obviously going to have a different curing time than if you need a low compressive strength result of 170 kPa, then we only need 80 kilos per cube, depending on obviously environment conditions. But yeah, normally as a rule of thumb, 24 to 48 hours, no walking. And then if you want to do work on it, if you want to walk across for it, then just you cover it with some sheets, you'd be fine. After 7 days, you can put new floor coverings on top of it.
Yep. So obviously you have various mix designs to suit different situations. It's not a one mix design for all situations.
No. We play around with the cement content, and if we really want to get to strong results, say for example, a hollow core block fill wall, like a Basablick wall, and if you want to reach about 12 MPa, we need to add a bit of sand, maybe some fibers into the mix to get to that compressive strength result. We can get with no additives except for EPS cement and our binder, we can get to about 6 MPa. And then after that, we have to add some more cementitious, or not cementitious, but more stronger components, some additives and some sand, maybe some fibers.
And I can see that you're keen on sourcing local cements as part of the whole Australian made.
Absolutely.
What consideration have you made for even better CO2 savings through greener cements, or do you need ordinary Portland cement to make it work?
When it comes to insulating screeds, if you want to get a really high insulating material, like you've seen in the video, we need a CEM1. So we can't really go around using anything to do with an LC3 or anything with tailings. But if it's a void filler, we can definitely use the new type of cements that are coming out with fly ash and with the tailings that are inside
and
so
whatever.
Definitely. If anything, that will only aid into the structural integrity of the product.
Yep. Cool.
Thank you, Stephen. And finally, Andrew.
Walter, you've answered most of my questions, so well done. And thanks for the presentation. Just a couple of things. from your website, I got the impression that one of your clients was Transport for New South Wales. Is that right? That you've
we haven't done any work with
I
Transport
was
New
just
South
wondering if
Wales.
you had it. It's good to know, and previous applications, because what we do is we look to see where has it been used before, because in the
Yeah.
sense you've put it down in the ground in the road sector, we look at what you've done and how it's performed. So it's important that I think you continue to catalogue those as examples. The other thing you spoke about, in addition to cement, there's a bio component. You spoke about aerogel. What is the bio component?
The bio-based binder that we have is a polymer modified binder that comes from naturally silica-rich waste that we've developed in-house. Yeah.
So it's another waste product that's utilised.
It comes from naturally silica-rich waste. So the bio binder is the majority of the components in the bio-based binder is from naturally silica-rich waste, which is a polymer modified binder, and you got a few very minor components that just add into the plasticization. And
thanks, Walter.
Thank you.
Beautiful. Thank you, panelists. Walter, there are 8 questions in the Q&A if you'd like to jump in there and type out some answers. And I will ask Gerard from Link Asia Pacific to please come on and tell us about your sleepers.
Good morning, everyone. My name is Gerard Klooster from Link Asia Pacific. We are Brisbane based. We are the agents for KLP hybrid polymer sleepers, made in the Netherlands by a company called Langhorst Engineered Products. Now, on the first page visible on the screen, you'll see a couple of slides. This basically tells the story, the journey that KiwiRail took. Left top, you see a rotten sleeper, timber sleeper, basically with a life expectancy normally of 25 years, in this case seeing less than 8 years. So KiwiRail was looking for an alternative option. They went for a composite product, composite sleeper. Tried that for about 3 years, were not happy with that, and basically went to open tender for other alternative composite sleepers. There were 7 tenderers, and ultimately the contract was awarded to Langhorst Engineered Products and ourselves. And you see bottom right, you see there a number of mainline sleepers, optimized sleepers that go into a tunnel project. Give you a bit of an idea of the scale. Sole supply for 3 years. That was extended by 2 years, and we are now extending it for the 3rd time, or they are extending it for the 3rd time, I think showing their happiness with the product. Left bottom, you see a turnout being assembled and installed in the KiwiRail track. Now, the question is, of course, what makes the difference between our product and others? And that it has to do with design on the one side, on the other of the materials. Next slide, please, Lauren. So the first product that we use is 100% recycled ductile polymer. The HS is high strength. It means that this product has the strength and stiffness at 60 degrees Celsius that the normal product used in Europe has at 25 degrees Celsius. So it's high strength for the temperatures that we experience in Australia. The product is 100% recycled material, so it is also 100% recyclable, meaning that at the end of life, you have 2 distinct products, the stiffener and the polymer. They can be separated from one another. They can be basically reused and made into a new sleeper again. So that's a circular economy. And you can, on an ongoing basis, every 50 years, you can recycle the product into new product. Because it's ductile, it dampens the impact of sound, and compared to a timber bridge or bridge with timber sleepers, it achieves a reduction of 3 to 5 decibels in sound levels. That's half the sound. The plastic or polymer also insulates against electrical current, so you don't have any signal problems between left and right rail. And the polymer encapsulates the steel bar. Because it's ductile, it can bend, it can flex, it can expand and contract over years and not crack, and thereby maintaining it totally insulated, so impervious to rot, to pest, to chemical exposure, to saline environments, etc. Because of all this, you have a 50-year design life. We have an 18-year in track so far and no problems. Also, our product does not contain any fibers as stiffener. That's what you will find in most other products. And the fiber causes problems when you drill it. You get fibers in air suspension, which is a safety hazard. Not so with ours. Finally, the product was aimed to be a replacement for timber, and it handles machines like timber as well. Next slide, please. The other material that we have is the steel rebar that you can see across the length of the product, one in each corner, 4 of them in total. It's ribbed, so it has a good physical interaction with the polymer that it is surrounded by and does not move inside the polymer. It basically has with the steel, it gives a high stiffness, and we are aiming to have a stiffness comparable to the timber that we replace, which in essence helps you to intersperse. You can take timber sleepers out and you could put our product in, because the bending stiffness is very similar to that of the steel it replaces. Steel has a low thermal coefficient of expansion, slightly higher than concrete, slightly higher than timber, but a lot lower than plastic, a lot lower than fibers, and therefore the stability, the gauge stability over a wide temperature range is basically guaranteed. And then because of the steel, if you have a derailment or you have some sort of extreme overload situation, you will find plastic deformation, but not a brittle fracture. So next slide, please. Here we see an installation. The left one maybe might look familiar for those of you in construction in Victoria. This is done in Ballarat. There we had about 144 sleepers supplied and installed at an entry onto a bridge, across the bridge and at the back of the bridge. That was installed a few months ago. So far, the feedback from V-Line is that they're quite happy with that. The next picture is a picture of an installation in Perth. 30 sleepers are installed. This is using existing ballast that they have instead of new ballast. They want to see, and there's a comparison with timber, seeing how it compares to timber and some other products. Was also fairly recently done. And then at the bottom, you see a breech. Now, the breech makes it special in terms of showing how strong and stiff our product is. It's only supported at 2 points. You don't have the full ballast bed that supports it. And only sleepers that have the required stiffness can be used and not bend in that application. And that is what we can achieve with changing the diameter of the steel rebar that we have and changing the height. You can see the guys working there with standard equipment, top left and top right. And the next slide, please. We can see how the product is used like any other timber material. The equipment top left handles the same as the standard equipment being used. You can mill it, you can drill it, you can cut it, and you can screw fasteners in with power tools, as you would do with any timber sleeper. So there's no special training required. You can just do it. Paperwork, always important to have as background. The next slide, please, Lauren. On the paperwork, we have provisional type approvals from MTM, Metro in Victoria. We have also provisional type approval from V-Line, and we have a full type approval from Kiwi Rail, who's been using it since 2019. Next slide, please. This obviously is an important point for you as audience, is the recyclability and the CO2 footprint. So the left 2 columns, the blue shows the amount of CO2 released during manufacture. The green lines, next line, shows you the CO2 released during transport from Europe to Australia. The third one is local transportation from harbour to point of installation. And the orange column is the reuse, recycling, or disposal of the material. So what you see is with the KLP products, 2 different products. The one is optimized, has a very low material footprint, and therefore only 35% compared to timber. The next one is the more sturdy one that has been installed by V-Line and by MTM. that has only uses 68% of that of timber. Then we just showed that if you were using virgin material instead of recycled polymer, the blue line increases in height by about factor 5 compared to recycled plastic, recycled polymer. And then you have the timber, which does not use anything for production. It actually stores it during growth, but then releases it during transport. The timber has roughly a 20-year life versus 50 for the composite. So there's a lot more transport happening there. For the yellow bar is a lot bigger. And the orange is basically decomposing, losing its weight as it decomposes over a 50 years life cycle for 2.5 sets of sleepers. Finally, we've got the concrete local concrete sleeper, which has a high content in manufacture and then low in terms of transport and recycling. But you can see the relative importance and the gains to be made by using KLP, as you see on the left-hand side. Next slide, please. This is a little case study. This is a sleeper that was installed in a coal mine in Germany in 2008. There's a letter with wording at the top that you may read at your own leisure. The axle load is 25 tons in this case. It was installed in 2008. It had seen 320 million tons. And basically, we did a 3D scan of the product showing that it stayed within the original specification of flatness. On the scale on the right-hand side, you can see that it is within plus minus 1.4 millimeters out of plane variation. Last slide, please. You see on the left-hand side the tunnel that Kiwi Rail was using composite sleepers. This is a special sleeper made as low as possible, 130 millimeters high. A viaduct in the Netherlands. The benefit with the viaduct is that you can make the entire viaduct lighter because you use lighter dead weight in that the KLP sleeper is a lot lighter than a concrete sleeper. And the third set of sleepers is the new Hedgehog, as it's fondly called. It's a new product. It uses less material. It's still recycled. It gives better lateral stability in track than even concrete, which is 2-3 times the weight. And it is shaped in a form where you can get the best benefit out of it. And finally, you see on the map where our products are installed. And that's the end of my presentation, and open for the panel for questions.
Lovely. Thank you so much, Gerard. I know you have spoken quite extensively with Stephen already, so I might throw to the other panelists first. Andrew.
Thanks, Gerhard, for the presentation. You spoke about you've had product in place for 18 years, and you predict a 50-year life. Presumably, the 50-year prediction is based on an appropriate type of test. Have you ever considered grabbing some of those sleepers from that 18-year-old site and actually extracting them and doing those structural tests to see whether the predicted performance, that you will get 50 years? Because I know you spoke about the 2008 doing a 3D scan on deformation, but have you done any structural tests on sleepers extracted from the site?
No, we have not done that. What we have done is part of the initial development testing was fatigue testing and cycle testing and exposure to 2 million cycles and measuring the stiffness before and afterwards and the degradation after 2 million basically fatigue cycles. I have the reports here. If you want to, I could send them through for you to have a look at. There's extensive test reports. I must say the product was developed in Europe. It was developed against ISO 12856, which basically caters for standard sleepers, for bearers, and for transoms. We have extensive test results, derailment, impact tests, etc. A variety of test results available.
So we know how you gave examples how the timber sleeper fails. How do these sleepers fail ultimately? What's the failure mode?
Good question. We've done a failure mode in an effect analysis, FMEA. We've got different modes of failure. The one mode of failure would be that there's just no steel on the inside, a manufacturing problem. You could have sharing of the plastic, of the steel within the plastic. You could have breakage of the steel inside the plastic. Those are the sort of things that could happen. We have done push-out forces to determine the shear force. We've done bending tests where you actually see the entire beam bending significantly, 30, 40, 50 millimeters. And then at some stage, you actually hear a snap when the steel breaks. But that isn't a severe overload case. That would be, factor 5 to 10 times the load that it would normally see. So to be honest with you, we don't. Somebody asked and said, how will it fail after 50 years? And I guess fatigue is probably the most likely scenario in there. And even then, you structurally have such stiffness in the polymer itself and the remaining three steel rods in there that you're not going to have any failure, not even on a bridge transom.
Yeah, I'm interested in terms of when you do your visual inspections. What is the inspector looking for? Why the signs indicating that there's a need to undertake maintenance, replacement, whatever it may be?
Yeah, there's another failure. Actually, I should mention that as well. The fasteners. So the fasteners securing the rail to the timber. With timber, you very quickly get rot, and basically the fastener does not clamp it at all anymore. With ours, with that product that came out after 18 or 13 years out of the coal mine, the plastic and the screw was still perfect. There was hardly any rust on the screw. It still was sat very tight. The polymer actually contracts around it and virtually basically seals it off, so it makes it impenetrable and a very durable, lasting product. We've done pull-out tests, and our pull-out forces are very high compared to the standards that we have, exceeding them by far. And that's another failure mode. So if you have a brittle product, the brittle product can, from impact and so on, start wearing loose. And we've heard that apparently does happen with some of the other products.
Okay. Thanks, Howard.
Okay, pleasure, Andrew.
Thanks, Andrew. Irina.
Thanks, Gerard. I have a question around the costs, I guess. How does this product compares to other similar products made also of polymer or recycled polymer? What's the ways to reduce that? And I've noticed that you're importing, I guess, the 100% recycled polymer from Europe.
Yeah.
And I don't know how that works if you kind of start manufacturing here, or
Yeah.
we want all the products to be here. Not to mention that at end of life, you would like to kind of recycle that again, and it should be locally rather than exported, is it?
Yeah. So good questions. Your first question in terms of how does the cost compare to other composite products? It compares very well, very favorably. We basically have 2 or 3 key competing products. To the best of our knowledge, ours is the cheapest of them all. There is a cheaper product available as well. There are cheaper products, but they would not provide you the functionality that is required. So they would not provide you the stiffness required. They would not give you the durability. So it's pretty cheap. You brought up the point of importing it. And obviously, from an environmental perspective, that is an important consideration. A, the cost, but B, the impact of environmental benefits to Australia itself. We are looking at locally manufacturing. It's an investigation that's underway. There's 3 things that need to be done. We need to make sure that the quality and quantity of raw material that we can get in Australia meets the requirements of Landcost from a quality perspective. We need to make sure that the demand for raw material for our products is sufficient, that the supply is enough, and that there's sufficient demand as well to justify the investment of producing locally. And thirdly, we need to make sure that the costing, the prices is acceptable to all parties as well. If we have met those 3 requirements, we will locally produce. But even at this point in time, our cost competitiveness is there. Timber is cheaper, but timber, the prices are rising fairly quickly, and the longer the timber that you want, the more expensive it becomes. And the durability has gone down. In the past, you had creosote, which gave it 25 years plus. That's down to 10 or 8 years now. And we increasingly find from our clients that replacement of timber is becoming an issue.
One more question. Have you considered other type of structures or products apart from the sleepers?
Yes, we have. We have with KiwiRail, who has been our primary client locally. We've done a number of different investigations on some other products as well. So yes, we do definitely. We see ourselves as innovative. The picture on the right-hand side, or just to the left of the map, is our new product that's under development. It will be on show on Innotrans in Germany in September. May I ask why? Why do you ask? What do you have in mind?
Oh, I don't know, maybe use in retaining walls or some other kind of structures. Like, can that product be utilized to create, other elements that can
Yeah.
be in infrastructure?
Yeah. Look, retaining walls, there's a number of products available. Ours is really one that looks at heavy loads. So our axle load is 25 to 35 tons. That's a very high load. Structural walls would be a lot less, I think. And it is a fairly costly product. So if you look at Bunnings, the sort of things that you can get for, for gardens and so on, there's a lot of cheaper products.
It could be like drainage pits or kind of end walls and stuff like that. I mean, I don't know. I'm just throwing in some ideas, but I wasn't sure if you're considering that. That's all.
Okay. Yeah. Yeah, we're definitely open to the idea. So if anybody has ideas, feel free to come and talk to us about that. Yeah.
And last question, do you see any barriers, anything that you think, you'll benefit from, I guess, in terms of help, I guess, from the panel or from, the industry?
Barriers to entry.
To kind of continue to, utilize your product and.
No, I don't see barriers. I think you see the biggest barriers as being two things: unawareness of the products that are available, and unawareness of the differences between the products. They all look fundamentally the same, and that's what I try to emphasize on the materials that we use and the benefits of using those materials. So. Yeah, and by the way, in terms of cost, the fibers that the others use fundamentally is a more expensive product than the steel that we use. So that was one of the benefits. But back to your key question, I don't see key barriers apart from being unfamiliar with the product, but that is rapidly changing now.
Thank you.
Thank you. And finally, Stephen.
Yeah, I might just jump in. I suppose, Gerhard, when do you expect to have full type approvals for mainline use with the Victorian operators? And I think you've got conditional maybe for select situations, and that's always the trial. You walk before you run with the rail authorities. But time-wise, when do you expect to have full mainline, all track classes, all speeds, all axle load situations allowed?
Well, it's an excellent question, Stephen. You bring up a very pointed one, and that probably goes back to Irina's point as well on her last question. To be honest with you, we find that the Australian industry is extremely conservative. So it does everything on sidings and turnouts at low speeds and so on. So to be honest with you, I would hope that we would get that in the next 3 years. But if you are willing to help and support us bringing that awareness, and I'm keenly looking for anybody that's willing to take a risk and take a high speed, high duty track. We have it actually in KiwiRail. That tunnel is that is a main line that they're using. The speeds are not that high, I think 80, 90 kilometers or so. They brought that down to 40 kilometers with the old track in the tunnel because it was outdated and the train was swinging from left to right. But if I could help you ask you for help and support in that would be great.
I'm interested in that hedgehog one as well. I don't think you showed us that in our offline discussions. How new is that one?
Very new. This is basically undergoing first test. We've got the first sort of off-tool samples. This will be on show at Innotrans in Germany, which is a major rail show in Europe every second year in September. So this is hot off the press. The key thing, so it's the benefits are fundamentally that the stability better than concrete in lateral stability. It basically What you do find is a sagging of ballast and a pumping of ballast, which this one will do a lot less. But it will probably still be another 2-3 years before this one really goes is ready for production and installation.
Yep, that's good. Thank you.
Thank you so much, Stephen. And Gerard, I think there might be some questions in the chat for you if you'd like to pop in and type some answers. Next up, we have Chris Rayson from Spider Tie. Chris, if you'd like to turn on your camera and mic.
Is that working?
We can hear you. I can't see you yet.
It's been disabled by the host. Is that better? Can you hear me, Lauren?
I can hear you, yeah, and we can see you. Okay, take it away.
Okay, fantastic. Well, good morning, everyone. I'm Chris Rayson, the Director of Spider Tie Australasia. I'd like to thank Lauren and her team at ecologiQ for the opportunity to showcase Spider Tie concrete formwork system. Next slide, Lauren. Our company manufactures Spider Tie concrete formwork system. It's designed in the USA, but now manufactured in Australia from 100% recycled polypropylene. This system's used for structural and cellular concrete purposes. Got a small video to play showing the encapsulation process. If you could play that, please. So this video is fairly old from the US, just showing how houses were built in its original design using timber, which we're not doing in our construction in Australia. We're actually using light gauge steel frame and developing cellular concrete with help from Swinburne University. But the spider ties themselves, you can see in the video, clip together. They form a wall system that can be filled with, as I said, either structural or cellular concrete. So the plywood is only a temporary form and can get reused on other jobs. Video goes for a couple of minutes, but when the plywood can either, as you can see, be put in box sections and assembled or assembled on site. So currently we're doing a job in South Australia, building a big concrete pit for the grape industry. That's in production over there. But the other thing, we're working with CSIRO to develop monolithic fireproof houses. So you can see in the video here that the spider ties are getting attached to the house, and it's ready for you'll see in a second, a pour that goes and creates the wall system and then continues over the roof to give you a monolithic coverage, which then in a fire situation can stop ember attack from entering the building. With the university, as I said, we're developing cellular concrete, and we are looking at using recycled products like waste from contaminated sites, and there was another product, biochar, which is made from waste timbers from construction sites, and these products can be added into the design mix to develop cellular concrete. And the main benefit of cellular concrete is its insulation qualities. And then if it's used in this system where it creates a completely encapsulated building, so as you can see that the concrete's very lightweight and about 25 kilos at 100 mil per square metre, and this can form a roof system creating an impenetrable barrier for ember attack. I think we might just go to the next slide, but it's showing you a monolithic concrete house here, which is indestructible, really. So some of the uses for spider tie being retaining walls, acoustic fences, pits and pools, commercial, residential construction, and in roadwork construction using the cellular concrete as well. Next slide, please, Lauren. The future development, we're working with Swinburne University in a collaboration to develop the cellular concrete products using the recycled products I mentioned before. There's a company in Dandenong producing a sand, which is a recycled product from, what I said earlier, from contaminated waste sites. So the price is quite cheap compared to conventional sands from the quarry, making it more competitive. Next slide, please. So these are my contact details, just showing how we can be contacted if there's any projects that we could be involved with and trialling with the university. I've had another meeting with RMIT earlier this week, who are also trialling using products like coffee grounds and things in concrete, and they've had quite amazing results. And also there is another product that's designed in Australia but tested in the US, and they are carbon nanofibers, and they're getting quite amazing results, and we'll be continuing to doing testing with that product. Quite a short little presentation, but I'm open for questions.
Beautiful. Thank you so much, Chris. Stephen, if you'd like to go first this time.
Sure. Thanks for that. Yeah, look, interesting product, Chris. What are the alternatives you're competing with? Yeah, who's your competitor, and what's your competitive advantage over them?
Hi, Stephen. Well, what we're competing with is the way we're doing building in Australia, which is using bricks and a stick frame, which is very inefficient, and the bricks heat up in the Australian sun and transfer heat. So with the spider tie, it's a liquid poured system. So with cellular concrete, the walls can be poured in one day. So you're basically pouring the brickwork and the insulation at the same time. So it's a very quick, efficient way to do building. And it's not a new product. It's been used around the world for several years. Even in the late 40s, when Berlin was bombed, they developed cellular concrete for rebuilding Germany. So it's, as I said, it's a new product that we're working on, but a sustainable version. And the spider ties themselves, as I said, we're making from 100% recycled polypropylene.
And obviously, anything built with this form of concrete construction would be for quite a long design life, presumably. But have you worked out what the end of life recycling would be when you knock down such a house? Yeah, how do you deal with the fact that this material is in the middle of the concrete?
So when this product gets crushed up, all the products being the concrete, any steel and the plastic, which is all recyclable again. So everything for end of life, I'm not saying anything bad about polystyrene, but if it's been put in the mix, then it could potentially create environmental disasters for end of life, where our product is basically just sand foam bubbles, like a foaming agent to produce little bubbles to create the cavities create insulation. So that's where we've got nothing really in the product itself that can't be recycled at end of life.
Have you done any trials on actually deconstructing it and using the raw ingredients to make the product again or make other products at the end of life?
Not yet, Stephen. The product's only been in Australia since the start of this year. We've flown the mould out from the US, and we're now manufacturing them in Pakenham, and they're made out of with an injection moulder, and that company can source recycled products. So we haven't built enough to start pulling them down yet.
Yeah, no, that's all right. Just I wonder whether you try to prototype, deconstruct, just to see how it went effectively.
Well, we will be doing that, Stephen, because working with the university, we've offered our facility to do field trials. So we'll be building some things here, and then we can try and pull them apart when that process is over, and see how the recycling of it, how they separate.
And I suppose, do you have the product able to do different thickness walls when people are after different levels of sound, thermal, or even fire? Bushfire resistance. Or an architect may want for other reasons. Different thicknesses. Do you have a range of products to enable different wall thicknesses?
So right now in Australia, we have a 200 mil wall thickness and a 100 mil, which is traditionally used on the roof. But there are other moulds available in the US up to 300 mil thick. So it's just a matter of flying the mould over like we did the first time, and we can produce different thicknesses if we've got different markets for it. But the particular mould that we've got makes the two different sizes. So between a 100 and a 200 mil spider tie, and they clip together and they can be curved. It's very easily to use bendable plywood and make curves with them and different shapes, like you can see in the picture in the background. So there's really not much else on the market that is available for doing curved walls. Currently, we're building a lot of swimming pools with them in the US, and my partner is developing housing for veteran housing in the US. So they're something we're working on. It's a bit of a collaboration.
Yep. Have you actually looked at the bushfire resistant building market?
Absolutely. We're working with Justin Leonard from CSIRO, so very closely with them, and he's wanting us to build a house and take it up to Mogo, New South Wales, for some bushfire testing. So we're very much all over that, and we speak with him on a regular basis, and we're just waiting for some of the test results coming back from the university so we can start building our little toy house to transport up to New South Wales.
Sounds good. All right, thank you, Lauren. I'm good.
Well, thank you so much. Thank you so much, Stephen. Irina.
Thanks, Chris. Obviously, the product, or should I say the system, is very specialized, especially for fire resistance and all that in housing or buildings. So I guess if you compare it with what's used on Australian market, this type of construction would be much more expensive, is it, per square meter for a standard house? Is that how it compares?
No, I'm thinking it's the opposite, Arena, because bricklaying is very slow in Australia, where this formwork system is fairly quick to install. And as I said, it does, say a traditional house would get poured in one day. So speed-wise, it's going to speed up the process for building rather than, conventional building. If you go to most estates here in Victoria, they'll all be brick veneer builds, which are very slow and energy inefficient.
Do you find that potentially there's a problem for labor shortage, for this type of construction? Because obviously that's the other reason for probably.
What I'm finding is most builders, third generation builders, they're not really eager for change. They've got their systems. They've been building like this for all their lives, and that's the challenge we have, is to introduce new technology. But we've got a few builders on board, and we've got a few projects on the go at the moment where we've got customers that are willing to trial this technology. So we're working with that, but using the recycled components, we're hoping to market this through government projects as well. If anyone's got anything available for us to do a building or a trial or a retaining wall or sound walls, that type of thing.
The other thing I was going to ask is, you mentioned roads or infrastructure. What type of products you actually make in the infrastructure space?
So it's with the university, we're developing this cellular concrete. So it's like a little bit like Walter's product, where it's a filler, but it's just made from these recycled components. So it's an ongoing collaboration with the university, where we're doing ongoing trials and testing to reduce the cement content, to find replacements, whether it be anything from coffee grounds to to recycled sand. So it's not just a one product, it's just an ongoing development.
I mean, does that fit in and it's within the standards, performing within the standards? Because obviously you consider this as a masonry product, I would say, is it? For partitioning and other.
I mean, the spider tie itself can have either a structural concrete added or this new cellular technology, or even Walter's product can go into it, just depending on the application with spider tie. But I guess we've got a double thing going on, where we've got the spider tie in one hand as a building construction product, and the cellular concrete, which has got many uses, whether it can fill the spider tie or get used as a product on its own.
So what sort of standards you would use to demonstrate kind of the compliance or the structural integrity of that? Because obviously we're talking about a composite system here. Many elements will give a little bit, and because the minute you change your concrete or it will be different.
So that's what the university, and unfortunately Professor Sanjan, who was going to come up for technical questions, is not available to speak on that, but he had another meeting to go to. So that's where, as I said, any of the technical things and standards were being, that's where the university, or they've got a multi-million-dollar concrete testing facility there in Hawthorne at Swinburne. So that's when they're getting involved more than ourselves on the more of the standards and the testing.
So that's like a work in progress at the moment, yeah.
That's correct, yeah. It's only very in its infancy. We only had Professor Sanjan and his student come out to visit me this week, and another meeting with RMIT. So that side of it is only very much in its infancy. But however, the spider tie is a product we've been manufacturing all year, and we've got several projects on the go currently, where we're building secondary dwellings like granny flats and swimming pools and concrete pits, that type of thing.
Okay. All right. Thanks for that.
Yeah. Thanks, Irina. Andrew.
Thanks, Chris, for the presentation. You've answered most of my questions, but just confirming, so the spider tie, there's no barriers now to using a spider tie, but the system that you're developing at the moment is, if someone wanted to build a house, design a house, it's still, your product would still have to go through some form of testing assessment to make it code compliant, or to provide the information for design to actually use your product. Is that how you see it?
So we're working with a local structural engineer who's already provided engineering on this system, where we inside the spider tie, we're using a light gauge steel frame. So the steel frame is providing the structural engineering for the building, and the foam filler, whether it be our product or even Walter's product, for example, is just used as an insulation and a fire barrier.
Yep. And you said you were developing a cellular concrete. So how far away is that?
So we've given the university this week, we've given them sand samples from a company called Renex in Dandenong.
Yep.
And that's made from, it just looks like sand, it's jet black, but it's made from contaminated soils. And they've got a lot of product available, 100 tonnes sitting there in Dandenong. And they're saying that they would be able to supply us. And because when you're building your cellular concrete, it has a lot of foaming agent put into it, so you don't need as much, some concrete slurry. So about 4 cubic meters turns into 12 when you're adding the foaming agent.
Right, and I suppose if you're looking at sand, then there's an opportunity maybe to use, the recycled crushed glass that's available. That's also been used in civil works as a sand replacement.
So all of those type of products, both universities and both professors that I'm dealing with at RMIT and Swinburne. So we're sort of working together, the three of us. And so they've all got their little pet projects. So the professor at RMIT, they're experimenting with putting coffee grounds in concrete, and they've had some quite good results. And there's another Australian product called Edencrete that was developed and now in the US, and they're having amazing results by adding carbon nanofibers into the concrete mix. And my partner from the US rang me and said that that they've had nearly 10,000 PSI, or equivalent to 60 MPa, out of the tests that they're producing in the US. So that company is based in Australia with that carbon nanofiber technology, and we can take that product back to the universities and continue that with our trials.
Thanks, Chris.
Thank you.
Lovely. Thank you, Andrew, and thank you, Chris. There may be some questions in the Q&A if you'd like to hop in there and type out answers to those. Finally, I'd like to invite Lily Rose Palmer on to give our final presentation.
Thanks, Lauren. Hi, everyone. I'm Lily Rose, and I'm here today with Dr. John Steele, the inventor and director of RoboVoid, for our inaugural Where Are They Now segment. So this is just an opportunity for us to catch up with suppliers who have previously pitched at an innovation showcase and hear about what's been going on since. So next slide, please, Lauren. So RoboVoid is a recycled plastic void former for concrete that has been pitched to our panelists in October 2021. So Dr. John, since presenting at that innovation showcase, what have been the key milestones or projects that RoboVoid have been involved in?
All right, thanks, Lily. Yeah, I don't think my video is on. I think someone on your end might need to turn that on if...
okay, I'll...
yeah, I think there we are. Okay.
Thank you.
Thank you. Yeah, since 2021, we've, I guess, travelled a long way to get our product into the market. At the time, we were in the thick of a extensive research and development program, and we were fortunate to get support from the likes of Sustainability Victoria and the federal government's CRCP R&D grant program. And we were able to work with some great collaborative partners, including Swinburne University, RMIT, Westcon Precast, and a few other industry partners, which helped us progress the technology. I guess from our concept back in 2018, we have now got it into the market where we are today. Yeah, also we're very thankful with the opportunities that ecologiQ's given us along the way. Being able to present back in 2021, that was great for us to showcase our technology to industry. And we also exhibited at a number of ecologiQ exhibitions at the exhibition centre, I think in 2022 and 23. Unfortunately, I don't think there's one this year, but we hope they're coming back next year, because we found that they were a great forum for networking. I think ecologiQ's the great thing about ecologiQ, it brings together a lot of the sustainability champions across industry. and has really created a great network to share information. And yeah, so one of the things we applied for was the Recycled First competition in, I think it was 2022. And that was to be involved in the Keon Park level crossing removal project. To be honest, we thought it was not going anywhere, but I think it's just infrastructure projects take a long time. So that's something you have to get used to. And but we're really excited to be involved in that project, and really appreciated the support of the project team, particularly Kate Rowan at John Holland, the John Holland Group, and Landscape Plus. They were the installer of the product into the in situ concrete slab there.
I was out there last week. It looks beautiful, Keon Park. It's fantastic. So it's a great project that we're very glad we were able to help support you be involved with.
Yeah, it was a really great project, and they did a lot of other sustainability initiatives. So I think it's really good to see the Victorian Government, supporting these initiatives, and I hope we see more of that going forward, because I think it's quite a unique approach. Even interstate and internationally, you don't see this government support being put into transitioning the construction sector. So yeah, hopefully that keeps going, because as we all know, we need to address global climate change and tackle the big issues of plastic waste and all those sorts of things.
Definitely, 100%. So harking back to the pitch that you presented at in 2021, was there a piece of advice or feedback from panelists that helped to shape your decision making, or even help to build awareness within industry?
Yeah, I think the feedback was particularly good, particularly in understanding the approvals process that's required to go through for infrastructure projects, which is a higher level of oversight than you would get in a typical construction project, which is completely understandable, because these are assets that last for 100 years. Compared to a normal building project, which might only have a design life of 50 years. So, so we were able to, address those requirements, demonstrate that our product can be used in construction and comply with all the relevant standards, including AS 5100. And so we, the engineers KBR on the project were able to integrate our product into the design, and get sign off with the asset owner, which is the Metro Trains Melbourne, I think it's called. So that was really good news for us, and so really good to get it on the first infrastructure project.
Yeah, wonderful. So I hear a few benefits from pitching at the program and engaging with industry, and helping to get the different approvals, etc. But have you experienced any challenges breaking into industry, or just in terms of industry engagement and uptake?
Yeah, so I guess from where we were starting, more of a research project, and initially people a bit nervous about being the first one. So having a bit of a helping hand to get us into projects is much appreciated. I guess, obviously we need to do a lot of work on raising awareness and providing the technical literature that enables people to specify our product. And we've developed our design guide to help facilitate that. I think we're up to the 5th revision now. And it's all been underpinned by hundreds of tests. So that helps develop the confidence. And then as people see our product being implemented, then that's starting to get a bit of a snowball effect in terms of inquiries that we're receiving. So we're really excited about the next steps.
Yeah, wonderful. And, in terms of, those challenges and breaking into industry, what did you find that, engaging with programs like ecologiQ and with, say, for example, sustainability champions sort of helped to sort of mitigate some of those challenges with engagement and industry?
Yeah, that's right. So I guess engineers normally like to design how they always design and do what they know best, which I guess that's understandable. They've got the experience and confidence in that. So to make them shake up the thinking a bit, having sustainability champions on the projects really helps bring that edge to the discussion. And so engineers are used to mainly dealing with designing efficiently for cost and speed of construction, but adding the sustainability angle on as well in terms of achieving CO2 targets. We of course also have to address the cost and speed, and that's why we make a very cost-effective product. We've got a highly optimized product which minimizes the amount of plastic that we need to use, and we have automated manufacturing methods which achieves a cost-effective solution.
Yeah, awesome. And maybe we'll just flick to the last slide, Lauren, if that's okay, for the final question. In terms of where you'd like to see industry and the future for RoboVoid, what would you like to see in the next 5 years?
Yeah, well, I guess the amount of inquiries that we've received is absolutely amazing, and if we can just see that those inquiries bedding in over the next 5 years, I think I'll be sitting on a yacht in the Mediterranean somewhere.
I hope that's you in the next 5 years.
But unfortunately, construction projects are a very slow infrastructure. So we're waiting with our fingers crossed, but also putting a lot of efforts into proposals, just improving our offering all the time.
And I think you've mentioned previously that, in terms of general industry changes looking ahead, you mentioned, factoring in carbon and carbon reductions. So, in terms of sustainability considerations in future, is there something that you're hoping that, we will improve at as an industry?
Yeah, so if carbon pricing becomes more integrated into the decision making, that would be very helpful. I think we see that shift happening overseas, particularly in the UK, where they're putting pricing of carbon into the thought process at an early stage. So it's not just about star ratings. Star ratings are fantastic as well, and we're seeing that become more prevalent in building as well as infrastructure. So the more these initiatives get bedded in, and the more it can influence the design early, the better. Because if we have to come in later and try and get the design changed at a later date, it introduces a bit of a waste and extra cost into the process because engineers design things twice instead of once.
Yeah, the age-old problem, getting in early.
Yep.
Wonderful. Thank you so much for your time, Dr. John. It's been so wonderful to have you back and to hear how you've been since October 2021. Maybe we'll have you back in a few years' time and we can see how the yacht's going.
Yeah.
So thank you very much.
Thanks, Lily.
Thank you. I'll throw back to you, Lauren, for the end.
Thanks, Lily Rose, and thank you so much, John, for coming in and giving that update. It's always so fantastic to see some success stories from a product that this session was able to help really launch into the infrastructure space. Don't forget, everyone, all of our innovation showcase Presenters, including John and everyone from today, will be available on our innovation register, which can be found on our Knowledge Hub. If you don't have access yet, I'll pop the email address up in a moment, and you can reach out to us for access. Please do give us a few days to get today's presenters up there, though. Don't forget to save the date for Greener Infrastructure Week. John mentions the conference. No, we're not doing one this year, but we are doing a week-long series of events for National Recycling Week. We'll be announcing that in a couple of weeks' time, the full agenda, but lots and lots of events will be coming on for that. So please do keep an eye out. And finally, if you would like to contact ecologiQ about anything, these are our details, loads of information on our website. Follow us on LinkedIn to stay up to date with everything, and email us at the address there if you would like access to the Knowledge Hub. Thank you so much again, and have a fantastic weekend.